In this presentation, we will be covering various methods of data preparation. Due to the different methods that are required for summarizing qualitative and quantitative data, there are different methods of presenting the data based on the data type. We will begin by examining ways of presenting qualitative data. Qualitative data can be summarized in a variety of ways. The most common method is related to how often an observation occurs. This is referred to as the frequency. The data can also be formatted as a percentage, which may be important at times to summarize data on a common scale. Data is often summarized in a table, which can display the frequency, as well as quantitative summaries such as means, medians, etc. Or you could include information such as the frequency or percentage. In this example, we will see that there is a table that includes 4 columns and 2 rows. Here's an example of a table that is used to summarize qualitative data. The rows are the levels of the observation, while the columns are the summary types. We see that the data is summarized into 2 different ways. There is the frequency that each level of observation occurs, as well as the percentage. Additionally, the subtotals for each column are displayed at the very bottom row of the table, which is a very common practice. A pie chart is used to present data by comparing area. A pie chart displays the parts of a whole. If we sum up the percentages of each group represented in a pie chart, the total should be equal to 100%. A bar plot is used for presenting data as a position along a common scale. A bar plot can display the frequency that an observation occurred. It can also display more than one group for comparison purposes as well. The bars can be drawn vertically or they can be drawn horizontally. A horizontal bar plot typically is used when presenting data in ascending or descending order. A line chart can be used for presenting data as a position along a common scale. Oftentimes, the lines are drawn to look at differences over time. However, a line plot can be used to compare differences between 2 groups. A line plot is used for 2 main purposes. One, to present trends or patterns in the number of occurrences between groups, or 2, to present trends or patterns in the mean of a variable between groups. Typically, like already stated, the change of a variable is presented over time. And when more than one group is compared in a line plot, a separate line is drawn for each group, as presented here. A Pareto chart includes both a bar chart and a line chart. It is used to display both the frequency of an item and a cumulative percentage for that same variable. This example is useful in showing the number of patients discharged by quarter, which is represented by the bars, as well as the trend of discharges over time, represented by the line. You can see on the left side of the chart, the axis is from 0 to 120, which is the patient discharges, and on the right side, that represents the percentage. Now let's examine ways of presenting quantitative data. To begin, let's first talk about some of the commonly used descriptive statistics for continuous data. The first is a measure of central tendency. Now, these measures help describe the typical number found in a list of numbers. The mean is one measure of central tendency. The mean is the same as the average. It is computed by dividing the sum of all the values by the total number of the values. The mean is also the most common measure of central tendency. However, in situations where a list of continuous variables aren't normally distributed, the mean may not be the best estimate of what is the typical value. In these situations, the median is a better measure of central tendency. The median is the middle or the center number in a list of numbers. To determine the median, you must order your list of numbers from smallest to greatest, count the number of values, split that number in half. Whatever that number may be, count either from the lowest or the highest number to find the center value. The last measure of central tendency is mode. This is the value that occurs most frequently in a list of numbers. It is rarely used and is a poor way of describing the typical value in a list of numbers. Another way of describing continuous data is with measures of variance. These measures are a bit more complicated to calculate by hand, so I recommend using software for assistance. Variance is the first measure. It is the average of the squared standard deviation from the mean. Thus, standard deviation is the square root of the variance. Finally, the standard error of the mean is the standard deviation divided by the square root of whatever your sample size is. All of these measures tell you how spread out the data is. That is, how far away are the values from the mean. Quantitative data can also be presented in a table, much like qualitative data. Typically, we use tables to summarize the values that represent various methods of data aggregation. In this example, we are showing data to summarize Medicare payments for inpatient prospective payment system hospitals, IPPS hospitals. We see that this table includes 7 columns of data, including the number of observations, the average, the median, mode, minimum, maximum, and standard deviation for Medicare payments. The first row includes the column names, while the second row includes the values for each of the respective columns. Therefore, we can see that of the 153,600 IPPS hospitals, the average Medicare payment is $8,848.75, with a median of $6,393.74, and so on. So now, when depicting data for quantitative data, it's important to consider the values of central tendency and variance, but you must also consider how you will graphically display these results. We will be using various graphical methods. Some are easy to make and understand, while others are a bit more complicated. In this example, a histogram is one of the most common graphs which show the distribution of the data. Now, a histogram displays a frequency, or the density distribution, of a single numeric variable. It categorizes or sorts numeric variables together, and this is what's called binning. Now, binning the numeric variables into groups establishes the width of each bar in a histogram, and the height of each bar represents the frequency or density of each of the binned groups. The distribution can be described as normally distributed when the pattern follows a nice bell-shaped pattern as shown on the slide. If the histogram, however, has the highest point to the left of the graph and a right trailing tail, it is referred to as a right skewed or positively skewed. If the histogram has the highest point to the right side of the graph and the left leading tail, it is referred to as left skewed or negatively skewed. A bimodal distribution occurs when there is more than one peak in the data. In this example, we can see the peak of the histogram is for data ranging from around 0.5 to 0.55, and the values within this range occur around 1,200 times. A boxplot displays the descriptive statistics of a continuous variable, including the minimum, first quartile, median, third quartile, maximum, and potential outliers. The line that makes the bottom of the box, this is what represents the value for the first quartile. Now, the first quartile of a data set is used to represent the 25th percentile of numeric data. So in other words, the number representing the first quartile can be interpreted as the value at which 25% of the numbers in the data set have a value equal to or less than that value. For example, if ages of a sample of patients were evaluated and the first quartile is determined to be 15, that would mean that 25% of the patients in your sample have an age of 15 or less. The bold line in the center of the box plot represents the median. The line that makes the top of the box represents the value for the third quartile. The third quartile represents the 75th percentile. The number representing the third quartile is interpreted as the value at which 75% of the numbers in the data set have a value equal to or less than that value. So if there are another component of this is if there are dots above and below the boxes, these dots typically represent potential outliers. Now, an outlier is a value that is the distance or far away from other values. For instance, if the age of 250 years old were present in the data, this would represent a potential outlier. Potential outliers are determined on a box plot when the values in the data set that are lower than the first quartile minus 1.5 multiplied by the interquartile range are above or below the third quartile or below the first quartile. IQR stands for interquartile range, and it's calculated as the value of the third quartile minus the value of the first quartile. When outliers are not present, however, like we don't see any in this example shown on the screen, you see that these whiskers are drawn. Now, the whiskers are the lines protruding from the top and the bottom of the box, and they represent the minimum and maximum values. A scatterplot displays the relationship between two quantitative variables. A line is typically drawn through the middle of the points and represents the trend of the data, which is known as the best fit line. Now, although a best fit line is not shown here, typically the best fit line depicts the type of relationship between two quantitative variables. However, this can also be inferred based on the direction that the points are falling. If the line or the direction of the points is ascending, meaning going upward, this is interpreted as a positive association, much as like is shown here. If the line is descending, meaning values are going down, this is interpreted as a negative association. The slope of the line, which is how steep that line is, determines the significance of the relationship between the two quantitative variables. Now, a simple linear regression is the typical statistical procedure that is associated with a scatter plot. The simple linear regression offers information related to the significance and strength of an association. The p-value that is supplied for a simple linear regression establishes whether the best fit line has a slope that is significantly different from 0. A p-value is used for determining significance of a statistical test, like for a linear regression. The p-value now should be compared to a predefined significance level. This is known as alpha. And if the p-value is less than alpha, there's enough evidence to conclude a significant finding, while if that p-value is greater than alpha, there's not enough evidence to conclude significance. With regards to a linear regression, however, a significant finding means that the best fit line has a slope that is not equal to 0. This suggests that a relationship between the quantitative variables is significant. However, the strength of that relationship is determined based on the distance that each point fall from that line. So if there are many points scattered far from the middle of the line, the association between the quantitative variables is said to be weak. If the points, however, are close to the best fit line, much of what we would see here, the relationship is stronger. Now, the statistic that represents the strength of relationship is for the best fit line, or between the two quantitative variables. This is known as the r-squared value, which can range from 0 to 1. And the strength of the relationship between the two quantitative variables is said to be stronger the closer that r-squared value is to 1. A bar plot is used for two main purposes, like we already stated earlier. It can either be used for plotting the frequency for one or more groups, where the height of each bar represents the counter frequency, or it could be used for plotting the mean for one or more groups, where the height of each bar represents the average. Now, the bars can be drawn vertically or horizontally, like we stated already, and again, when it's a horizontal bar plot, it's typically presented in ascending or descending order. Now, when a bar plot is used for plotting the mean for one or more groups, The standard deviation or standard error for each level of a group may be added to the plot to show the range of data. When a large number of groups are compared in descending or ascending order, an alternative method for presenting the data is to use a dot plot. A dot plot is something that is not very frequently used. The advantage is you can actually overlay a dot plot on top of a bar plot or a box plot, which may be a bit more interesting so you can actually see the individual responses. A dot plot presents the frequency or means to compare many groups using just dots. And the dot plot, it offers somewhat of a cluttered view of data, but it can show each individual response for an individual in a group. Another common method to visualize data is by mapping the data out based on geography. Now, geocodes are used to present information such as rates or diseases, or average performance metrics and financial information based on location. And a geocode may represent a location at various levels. Most commonly, these levels include the city, the county, the state, or country. A heat map offers a similar view of data by presenting the severity of differences across a continuum of colors. Now, higher values are noted by one color, while lower values another color. The boxes may represent discrete categories such as locations or times, and this allows the identification of outliers to be more rapid. However, to find a typical value, it's often more difficult. In this example, the size of the boxes are related to the value, where a larger box is used for larger values. There are many graphical methods that can be adopted depending on your type of data, the audience you're presenting the information to, or your intended use of the graph. It's important to know your audience to ensure the most effective graphical methods are adopted. When in doubt, ask someone. It's okay not to know exactly how the information should be presented, and when that's the case, talk with someone about the most effective method. Always be willing to take and accept critique. People can be very critical if the information isn't presented clearly or in the way they expected. Therefore, make the most of the critiques by adapting and making appropriate changes. It's wise to keep any graph simple. As soon as you get carried away with colors or some fancy graph, you'll start to lose your audience. If a user can't interpret the graph quickly, it's a bad graph. Lastly, it's important for a user to identify the trends in the data, but it may also be important for them to identify the discrete numbers that are actually being represented. In this case, it may be best to present both the graph and the numbers to ensure a proper interpretation. In closing, data visualization can offer an excellent way of delivering a message about data effectively and quickly. However, this is only the case if a graph or a table is appropriate for depicting the type of data. When developing a graphical or table, know your audience and get buy-in to ensure that the data is being presented in the most effective way.